Welcome to Algebra 2, Semester 1, Unit 4, Section 4.3 to 4.4. This is the very first section of this unit. Unit 4 is a little bit longer unit. As you can see, we've got about 7 or 8 videos, and then you have bookwork between each of the videos. That's real important to be doing that bookwork in between so that you practice what you're learning. Don't just sit and take all the notes, you won't be as successful on the tests. Okay. Page 2 is vocab. It is in order, so if you want to just list in the blanks A through M, straight down the column, then you'll be able to study those and hopefully do well on that test. Okay, to the warm-up. You've been doing these for a while. I'm just going to go over them on the video, so in case you've been missing class, you can study how they're done. X plus 1 squared really does mean x plus 1 times x plus 1. Now, if you haven't memorized the pattern here, then I do expect you to go ahead and FOIL this. The first term would be x times x, which is x squared. The outside is 1 times x, and the inside is 1 times x, so I put those together. 1x and 1x is 2x, and then the last is 1 times 1, which is 1. Okay? Now, if you've studied the pattern and you remember what that perfect square is, then you could have just gone straight to that answer. That definitely would have required being in class and practicing. So in this one, if we FOIL it, you would write it out x minus 2, x minus 2, and then you would FOIL. If you're following the pattern, you know it's the first one squared. You know that it's the last one squared. So we get x squared, negative 2 squared is 4, and then our middle term is simply 2 times this 2 times x, so that would be 4x, and it does carry the sign of that term there, so it's a minus 4x. Okay, again, practice the pattern. First term, x squared. Last term, positive 9. It's the last term squared. And then the middle term is this sign, and it's 2 times this. 2 times 3x would be 6x. Okay. If you have not been in class, please use FOIL and practice multiplying these. So the first term squared is x squared. Last term squared is positive 36. And the middle term is negative 6x plus a negative 6x, which is negative 12x. Or 2 times those two. Here we have x plus 5. Go ahead and turn off the video and find your answer, and then see if you get the same as what I get. Okay, and the last one is x squared minus 8x plus 16. Okay, those are the warm-ups. Another warm-up here. How do we factor using the GCF? What we have to do is see what's common between the terms. 6x cubed minus 1 has nothing in common. And we can't even do a difference of 2 cubes because 6 is not a perfect cube. In this middle one, we do have a common term. 3 would go into all of these, as well as we have a p with all of them, so you take p to the lowest exponent, which is 1. 3p times 6p squared gives you 18p cubed. 3p times negative 9p gives you negative 27p squared. And 3p times 3 will give you your last term. That's how you would use the GCF there. On this one, the largest number that goes into all of those would be 2. The smallest exponent of x is x squared. Smallest exponent of y is y cubed. Parenthesis. 2 will go into 4 2 times, and now we just subtract x cubed. 3 minus 2 is x to the first. 4 minus 3 on the y's would be y to the first. Minus 2 times 3 is 6. We don't need any more x squared because we've got them, and we only need one y. Just subtract the exponents to get this. 2 times positive 4 is 8. X squared into x squared. We don't need any more x's. It goes one time. Y cubed into y cubed. It goes once as well. Last one. 2 goes into 10 5 times. X squared into x squared once. We don't need to put that. Y cubed into y to the fourth. We only need one more. And there's our answer. That's GCF factoring. Now, if you have been in class, page 3 is a review of class. I just want to go over it for those of you that need the added review or have not been there. So, in a 4-term, you underline 2 terms, and you take out the GCF, which in this case would be x. We have x minus 5. Then take that binomial and write it right underneath the other 2. And ask yourself, what could I multiply by x to get negative 4x? Be a negative 4. Does negative 4 times the negative 5 equal 20? Yes. Now we're almost done. See how this front part has an x minus 5 and this part has an x minus 5? Factor those two out. We get x minus 5. And what we have left here is x minus 4. Okay. Next one over here. 3 terms. The reason we've been playing the x game, we take the first and the last, put it down here, and we think of all the factors of 20. It's a positive 20 that would add to be positive 12. Well, if it's a positive 20, we know the signs have to be the same, and if it's a positive 12 that they add to be, then we know that they're all positives. So we start listing the terms. 20 and 1 multiply to be 20, but they don't add to be 12. 10 and 2 add to be 12 and multiply to be 20. So we have 10x, 2x. Now the whole reason that you do that x game is because you can't factor 3 terms. You have to turn it into 4. So this is our way to convert to 4 terms. We now have 4x squared plus 10x plus 2x plus 5. Now we can do just like we did on the last one, factor out what's common. 2x times 2x plus 5. Write the 2x plus 5 over here, and we can see from right above that 2x plus 5 is what that is, so it just needs a plus 1 out in front. We factor out 2x plus 5. 2x plus 5, and then we have 2x plus 1. Okay? Next one. Both of these have a shortcut. The first one, do you notice it's different from the last trinomial? The last trinomial had a leading coefficient of 4. This one does not have that leading coefficient of anything other than 1. Since it has a 1, we can simply find our 2 factors that multiply to be 20 and add to be negative 9. So if we multiply to be 20, and that means their signs are the same, then we know that they must both be negative in order to add to be negative 9. So we could do negative 20 and 1, negative 1, that would be negative 21. Negative 10 and 2, that would be negative 12. Negative 5 and 4, that gives us negative 9. Now instead of plugging it into the x game and having to convert to 4 terms, it actually can be written right below it with those factors. Because it has 1 as a coefficient, you can do that. So it's x minus 4 and x minus 5. Okay? Next problem is a difference of two squares. These are really fast to work if you can spot them. Because you don't have a middle term, you know that it's wiped out. So you take the root of the first term, 4x, root of the second term, 4x, and the root of the last term. Okay. Next one is 3 terms. It does have a factor up here in the front that's bigger than 1, so we have to go to our x game. 6 times 5 is 30. That is a positive 30, so we know the signs have to be the same. Since that has a negative sign, we go with 2 negative numbers. Factors of 30, I'd go with 2 and 15. They add to be 17. 2 and 15. Bring down your x, circle those, and that shows you where you're going to write your 4 term. 5x squared minus 2x minus 15x plus 6. Now we factor out what's common. X, and we leave 5x minus 2. 5x minus 2. What times 5x is negative 15x? It's a negative 3. So now we factor out the 5x minus 2. And we factor out the x minus 3. Okay, next one, you should notice that it looks a lot like this one, no middle term. This is a perfect square, that's a perfect square. So go ahead and turn off the video and see if you get it. Okay, there's your answer of the difference of two squares. Go on down to the next one. We have a negative 21. What would it add to be 20? It would be positive 20 and negative 1. This time we have factors with the opposite sign, so you really are subtracting. So we have 3x squared plus 20x. I'm sorry, that should be plus 21x. It's got to multiply to be 21, plus 21x minus 1x minus 21. Okay. Now we factor out what's common here. 3x. And we factor out what's common here. As soon as we write this. X plus 7, and I apologize, I wrote a minus 21. This should be a minus 7, matching the equation from before. So that would just simply be a minus 1. So we have x plus 7 and 3x minus 1. If we look at this one, it might look like a perfect trinomial square. We've got a perfect square here, perfect square here. So let's check it out. It would be 3x plus 2. If we were to square that, all we have to check and see is if this times this doubled is equal to that. 3x times 2 is 6x. Doubled would be 12x. So that is our trinomial square. This one looks familiar too. It looks like it would be x plus 6. Let's make sure the middle term works. That would be 6x plus 6 more x, which is 12x. 6 times 6 is 36. Okay. On this one, we can go straight to our shortcut. X x. Now it's got to multiply to be 12 and add to be 3. And if we look through our multiples of 12, we've got 12 and 1, 6 and 2, 4 and 3. As soon as you make a list and you get to the halfway where you're headed back up the list, you can stop right there. None of these will subtract to equal 3x. So at this point, I would just write not able to factor. Okay. Next one, difference of two squares. Perfect square, x minus 7, x plus 7. Those are the fastest ever. Let's see if this is a difference of two squares, or I mean not a difference of two squares, a perfect trinomial square. So we have x would bring down the middle sign, minus, and 169 on your perfect squares is the square root of 169 is 13. So let's see if this works. 13 times x would be 13x, times 2 would be 26x. Okay, with that said and done, now we're ready to start solving these equations. Now it's kind of important that you know really what you're looking at when you're solving for a 0. So first thing we do is we set that y to 0, and now we're locating the zeros is what we call that, the zeros of the function. We say what would multiply to be negative 12 and add to be a negative 1. We know the first term is put in there as the placeholder at the beginning, and then we take negative 12 and the factors that would subtract to be negative 1 would be negative 4 and 3. What this means is that if you have two numbers multiplied together and they equal 0, one of these needs to be equal to 0. So it's either when x equals 4 or when x equals negative 3. What that means graphically, we've got a parabola, as you know, because it's got the x squared, so it's a U shape. It also, we know, is going up because it's positive out in the front. So we know that this parabola crosses through 4 and negative 3. Okay. If you have questions, mark it down on your paper and come to class with it. This one, go ahead and try and do on your own. Pause the video and come back to me. So it's 0 equals x minus 10. I was thinking other numbers, but x minus 10. I should say x squared minus 10x plus 3x minus 30. Now it multiplies to be negative 30 and it adds to be negative 7x. Okay, so we're in good shape. Factor an x out of there, x minus 10. Factor a 3 out of here. That would leave us with x minus 10. I'm sorry, x minus 3 times x minus 10. Okay. Graphically, what that means, the 0 here, x minus 10 would only occur when x equals 10. And the 0 here, x minus 3 would only occur when x is equal to 3. And in polynomial graphing this way, That means that the graph is crossing the x-axis at 10 and then again at 3. And you would just draw a big U shape in there. Okay, last little section. We need to solve for the unknown. These are a lot like what we were just doing. We circle the z squared. To get it alone, we add 5 to each side. We have z squared equals 9. Square root of z squared and square root of 9 would be z is equal to plus or minus 3. Okay, next one. We've almost got the r squared all by itself. Just subtract 7 from each side. We get r squared equals negative 3. Take the square root of everything. We have r equals plus or minus square root negative 3. And down below that, just make sure that I clearly have a sense that you know what's going on. You see there's no real solution. So we have some that try to have you find the solution. Number 3's work the same way. Go ahead and pause the video and solve it and then check your answer. Okay. Very last one, or last row, subtract 3 from each side. 4x squared equals 0, x squared equals 0, x equals 0. So on this one, we only have one spot where that graph's coming down and going tangent. Okay, next one is, I would divide 5 by each side to get rid of the parentheses. So you now have 1 plus, or x plus 1 equals 30. This is still squared. Now we want to get rid of the square, so we square root everything on each side. We get that x plus 1 equals 30 broken down would be 5 and 6. 6 is 2 and 3, so nothing gets out of prison on that one. So we have plus or minus radical 30. Now to get rid of this x plus 1, the plus 1 there, we would again subtract 1 from each side, just in helping get that x alone. I'm sorry, made a mess out of that. X plus 1. Okay, so we subtract 1 from each side, and we get x equals negative 1 plus or minus radical 30. Very last one, I'm going to let you try on your own. I want to see it when you come to class. Have a great day.